Kara. Go ahead, you're up.
Okay. Hi, everybody. So, like Gary said, we're going to be talking about winter flounder today, young of year, that were captured in Boston Harbor. Typically, I do yearly aging, but this project focused on daily aging as they were the young of year. So it's a little bit different for me, but we will get into it. Let's see. It lets me change my slide. There we go. Um, so this was a 3-year-long study in partnership with the University of Massachusetts Amherst and Massachusetts DMF, with the overall goal being to assess the spawning habits and habitat use of winter flounder in Massachusetts waters, specifically around Boston Harbor. And the overall goal, again, being to better understand their habitat use, their reproduction, and their growth. But more specifically for DMF and where I came in the Age and Growth Lab, we were using the young of year winter flounder that were captured and daily aging their otoliths in order to calculate an average hatch date. And that average hatch date was going to give us information that will help us more adequately manage the species. There were a lot of different parts of this project that happened, things with adults and tagging and things like that, but I only took part in the aging. So that's really what we're going to focus on today and in this presentation. So winter flounder themselves, they're a ground fish. They migrate between shallower areas and offshore areas. In the late winter and early spring, they're going to come into the more shallow areas like Boston Harbor, that's near shore. And they're going to spawn, lay their eggs. Those are going to hatch into larvae and hang out in the water for a little bit before they settle to the bottom, about a few weeks. And once they do settle to the bottom, they're going to take on the more flounder-like characteristics that we're used to. So that flat body, and one of their eyes, the eye on the left side, is going to migrate on over to the right side. And so that is what we're going to want to focus on from this slide, pretty much is the eye migration, because this is what we're going to call the settlement period. So when these guys settle to the bottom and transform into juveniles, we're going to be able to see that as a mark on their otolith. And that was important to some of that aging and dating that we were using. So just keep that in mind because we'll be able to see that in some photos later as well. As far as sampling, again, all of these were collected in Boston Harbor. There were weekly and biweekly trawl surveys that were conducted across a bunch of different depths. So there were shallow, mid-depth, and deeper water sites with a depth range of about 0.14 meters at the most shallow end to 12.9 meters at the deepest. They were conducted from summer to early fall, but most of it took place in the summer. Just went very little bit into the fall there, with about 1,000 to 4,000 fish in total being collected for each year, each sampling season. And this map over here on the right, all of those blue dots, each one is representing the starting point for a tow in the harbor. And this is for all of the years collectively. So all sampling seasons from 2021 through 2023. And you can see it's really pretty well distributed throughout the harbor. They had a lot of different sites going on, so it was very representative of the area. And here's some photos of that sampling and what it looked like. Again, I didn't go out on the boat. I just did the aging in the lab, but I got these a couple days ago. So it's showing where the tow is being pulled up, it's being dumped out and sorted through. And then that picture on the top right is all of those young of year that were collected on the measuring board. So they did take biological data on the boat and everything. Every fish had data associated with it and a sample number associated from the boat. And that little guy on the thumb on the bottom is just kind of showing you the scale of really how tiny some of these guys were that we worked with. So there's just a little visual of how it all happened before it came up to us in age and growth. So once we did get them in age and growth, our first step was to subsample them. So each year we took about 250 fish in our subsample, and it was a stratified subsample. So it was across the depths and the dates that were sampled, so that we were making sure we were getting good representation. But with that, we did have length and date restrictions. So we had an 80 millimeter cutoff length for our aging. We didn't subsample any fish above 80 millimeters, and we had date restrictions. So in 2023, we implemented a date restriction for the cutoff to be about the middle or end of September, whereas in the earlier years that we aged, we were aging fish that were captured through October. The purpose of these restrictions was just, ease of aging pretty much and time and accuracy. So as the fish get bigger and older, they get more daily rings for each day they were alive, they get more compact and can be a lot more difficult to age and take a lot more time to age. So that was the reasoning behind that. But once we got our subsample of about 250 fish, we then were able to dissect and remove the sagittal otoliths. So that's what you see going on in the picture on the left here is just my little setup of a workstation where I'm going to start dissecting those guys there. But we pull out those sagittal otoliths, we clean them, we dry them, we label them, and then they are ready to be mounted. So we adhere them to glass slides with a liquid cover slip. And at this point, you have that whole odo, so you're not going to be able to see those daily rings very well on it. You need to polish it down to make sure that you're going to be able to see all of it. So from the edge to the very center of the otolith. So that's our next step there. Our last step, number 4, is polish it with lapping film. We do hand polish them all down, which, as you can imagine, does take some time. And there's definitely a learning curve to it as well. So you have to be very careful to not over or under polish them, and with the goal of being able to see all of those daily rings. So once we do polish it, it's going to look like this. Again, just note the scale in this image. So this is a 1 millimeter scale. This fish was aged as being 76 days old. I feel like that's kind of in the middle or maybe slightly on the younger side of what we aged on average. So it's pretty solid example of the size that we were working with. And you can see here on the top right part of it, we have a really, really clear set of lines that we can easily count, right? So starting from the edge, we have some pretty dark ones, pretty easy to see. But as we get to the middle, we do get that darker section there where that arrow is pointing to. And then to the left of that, it's a little bit more murky. So this is just speaking to the difficulty of getting an even polish on them. They have different curvatures, the otoliths do, and as they get older, that curvature tends to change, and we have to adjust how we're polishing. But overall, this is what it's going to look like once you get that first set of polishing done. Now you'll remember earlier in the presentation, the first few slides, I mentioned we wanted to take note of the fact that they do settle to the bottom and transform into juveniles by changing shape and whatnot. So that's what we're going to show here. It's really difficult to see in this picture, and I'll show you a better one in a little bit. But this is what we're going to call the settlement mark. So there is actually a distinct line where the deposition patterns of those rings that are laid down has shifted. And everything inside of that is from when the fish was born until it settled to the bottom. And that distinct line is what we're going to call the settlement mark. So the day that it did settle and transform into a juvenile. So we'll just take note of that and take note that it is in that darker area here that we can't really see. So because of that, we do age and count in 2 phases. So phase 1 is going to be outside of that settlement mark. So from the edge of the otolith to the outer edge of that settlement zone, and it's going to be the majority of the daily rings. It's that really clear area that appeared first when we polished. And so we're going to get that count, we're going to write it down, and then we can go to phase 2, which focuses on lightening up that darker center. And that's going to be all of the daily rings within the settlement mark. So from the core of the otolith, the day the fish was born, to that settlement mark I pointed to on the last slide. This isn't as many daily rings in here, but again, it's all of that from when it was in the water column to settling at the bottom. And it's going to be darker and we need more polishing. So the reason we do these 2 phases is because we need to polish more for phase 2, and doing that is going to erase the lines that we counted in phase 1. So once we do have both of those counts, we can add them together. So phase 1 and phase 2 are going to give us a total age for each fish. Every fish is assigned a total age by 2 different readers. They're aged independently, and we did at one point do a comparison between left and right otoliths to see if there was a difference in how they looked or how we aged them, and we didn't see a difference. So basically we did it so each reader got either the left or right odo, it didn't matter, and polished that all the way through and aged it and assigned it a total age. So that's how we've got 2 total ages for each fish. This is just looking a little bit closer at that photo to show you these phases of counting. It's the same otolith I just showed you before, just polished down a little bit more. You can see it on the photo on the right. I outlined that settlement mark in white, so you can see it a lot better on here. Still not super clear as if you were looking through a microscope, but that blue arrow on the left is going to be your phase 1 of counting, so what appears first. And the yellow arrow is going to be that phase 2 within the settlement mark. The settlement mark does look different on each fish, so it's just something to keep in mind. You're not always going to be counting to the same exact point. So with these total ages that we got from each reader, we were able to compare them, and we saw that we did have really pretty good precision for our daily aging, with about an only 9% difference between total ages on any given fish each year. And we were within 10% of each other about 60 to 70% of the time, with our precision getting higher each year that we aged. So in 2021, we were within 10% of each other about 60% of the time, and by 2023, we were within 10% of each other about 70% of the time. And that's definitely keeping in mind some of those difficulties that I've definitely mentioned already. The fine line between over and under polishing. You polish too much and you erase all those lines and you can't get them back. You under polish and it's too dark and you can't read it and you're going to miss some daily age lines. With older fish, they're bigger, they have more curvature and more numerous and compact lines. That makes polishing a lot more difficult and counting a lot more difficult. There may be fish with one otolith for whatever reason we were only able to extract one from it, or you saw how small they were in that image with the scale, so you breathe in its direction and it's gone and you're left with one. And then definitely eye fatigue. You do a lot of work with your eyes, you go very, very tired eyes from looking at these guys, so that can definitely have some impact as well. But overall, our precision was really great considering all of these things. And now that we have those total ages, we are able to calculate our hatch and settlement dates, which was really kind of the goal of all of this. So our final ages are just strictly an average of the total ages given by each reader. Once we have that final age, we can subtract it from the capture date of the fish. That's going to give us our date that the fish hatched. And now that we have that date, we can go in and add the average settlement count to that date, and it'll give us the date of settlement. So we did that for every single fish in this study, and then all of those were averaged, and we were able to get average hatch and settlement dates, which is what you're looking at here. So we see with our hatch dates, we have 2021, an average hatch date of May 13th, 2022, April 15th, and 2023, March 23rd. You see 2021 is a little bit of an outlier, with it being further off into the year. We think it's probably just because that was our first year daily aging these guys, and there's definitely a learning curve. It definitely takes a bit to get a hang of it. But it also could be due to other factors, environmental factors that may have pushed that hatching season to be a little later, things like temperature. We haven't looked into it, but definitely a possibility. As far as settlement dates, we didn't take settlement data in 2021, so we don't have that, unfortunately. But we did get it for 2022 and 2023, with those dates being May 10th and April 20th, respectively. And we are seeing here that there's about a month difference between when these guys hatched to the date that they settle. Now we'll look at that in just a little bit of a different way. So this graph is just showing the hatching timeline. Overall, we're seeing this trend where hatching starts out slow earlier in the year, where it begins around January. It really ramps up in the middle, early spring, and then it really slows down towards summertime, with it hatching ending around June, depending on the year. But overall, we're seeing about 50% of these fish have completed hatching within the month of March. Again, 2021 was a little further out in the year. But overall, again, we're seeing a 5-month hatching period. So regardless of the year, it's taking about 5 months for all of these to begin hatching, and then all of these fish to complete hatching. That's the main takeaway of this one here. Similarly, this is the hatching timeline, compared to the settlement timeline. Our settlement timelines are the dotted lines, and our hatching timelines are the solid lines. So we are seeing similar trend in the settlement here, where it starts off slow, really ramps up, and then slows back down as we get further into the year. But we're also seeing a really good visual of how the settlement is happening about a month after hatching. The graphs line up fairly well in that aspect. And we're also, again, just going to mention that I didn't have settlement data for 2021, so we're only showing 2023 and 22 here. But for those 2 years, settlement was completed roughly by the end of June or July. And so that's meaning they've all settled to the bottom, they're starting to transform, or they have transformed into juveniles. We did look at average settlement age. In 2022, they were about 25.6 days, and in 2023, a little bit older, so 27.6 days old. We did try and see if they settled faster at different times of the year, thinking maybe temperature could have affected it, but we really didn't see a difference in that and how long it took them to settle to the bottom. All right. So this is just breaking it down a little bit more. Young of year hatched per week represented by week of the year. This is showing all 3 years, so 2021 in yellow, 2022 in blue, and 2023 in the purple here. We are seeing a distinct peak in each year where most of these fish are hatching within a few weeks, period. So in 2021, this is the end of April, beginning of May. In 2022, it's a little bit earlier in April, the weeks of April 3rd to 10th, I believe. And then in 2023, it happens about the end of March. So this is aligning really, really well with those average hatch dates I showed you in the initial table earlier. But what we're taking from these peaks and these concentrated hatching events is that there's likely a concentrated spawning event that the adults are participating in earlier in the season that is then leading to these concentrated hatching events. I think I just have one more graph for you after this, which is a length at age. So what we're seeing here, pretty good. What we want to see as far as the fish are getting older, they're also getting bigger. That kind of validates that we were aging them right, or as to the best of our ability. But I do just want to remind you here that we had the 80 millimeter cutoff length. So no fish were subsampled above 80 millimeters, which is why it tapers off at the end here. And then due to those kind of difficulties I mentioned before, as far as curvature, compactness of lines, and just different polishing issues with older fish, there's likely less accuracy with those older fish we've collected, which is another reason that graph kind of tapers off. But overall, it's a really good trend that we did want to see here. Just to wrap it up a little bit, the insight that we gained from all of this, we learned the young of year winter flounder in Boston Harbor hatching over roughly a 5-month period, settling within a month of hatching for the most part. And by the end of July, they've all settled and transformed into juveniles. So they're no longer in that water column as larvae, they're all on the bottom now. Secondly, main takeaway is that there are concentrated hatching and settlement events that are happening. And from that, we're led to believe that there is one concentrated spawning event happening in late winter or early spring, rather than a prolonged spawning season. It seems to be fairly concentrated. So those are our main points that we kind of want to remember and what we got from our daily aging, getting those hatch and settlement dates. Now, the implications of this are just that we can better understand when these fish are entering and exiting the harbor, and at different life stages when they're doing so. So when we might have a lot of fish on the bottom versus before they've settled. We can utilize these hatch and settlement dates to consider activities that might disrupt the bottom in that same effort. So things like trawling and dredging. And just in general, more life history information is going to allow us to manage them better and have a better stock of them. Would just love to lastly acknowledge some of the people that helped with this project. There were a lot of them, but mostly big thank you to the University of Massachusetts Amherst. Katrina Zarella-Smith, she's the PhD candidate that Gary mentioned in the beginning that we worked with on this project. She has done a lot and was our main partner on this. And mostly, again, the Massachusetts Division of Marine Fisheries, but everyone in my office in the fisheries researching and monitoring team for going out and grabbing all of those samples on the beam trawl, and all of my aging growth laboratory members for helping to process and work through all of that aging. Lastly, just U.S. Fish and Wildlife Service Sport Fish Restoration Program, because they fund all of our projects. And that's really what I have for you guys today. So thank you for listening. Thank you for coming. And let me know if you have any questions.
Thanks, Kara. I had a question. Did you line up temperature with those hatch dates to see if, let's say, 2000, I forget the exact year, but 2023 appeared to be an earlier hatch date than 21 and 22? Was there something
Yeah.
significant there?
No, we didn't look too far into that, honestly. I feel like there was something that was done as far as some of Micah's data with the adults, but it's not something that I have off the top of my head. I know I personally didn't look too much into it, but it was kind of assuming as well that that was our first year of aging. And we may have been, counting things that weren't actually daily rings or overaging because we wanted to, at that point, we were sharing otoliths. And so if I polished an otolith, I needed to save it so that it was still looking good for Christy to age it. And it was a little bit more difficult to get accurate ages that way as compared to both of us aging an otolith, which we switched to later on.
Sandy Sutherland.
Did you count the rings on the microscope, or did you take images and then count from that?
Oh yeah, we took them on the microscope. So that's kind of what we were looking at through the scope, but it wasn't from an image. I only took the photos afterwards once I had a few that were nicely polished, but we were just doing it through a compound scope with transmitted light.
Thanks.
Wayne Castengray.
Hey, Kara, great job. Two quick questions. Are you doing this for 2024? And then I know this one isn't really fair because it was beyond the scope of your project, but
Okay.
did anyone on the project ascertain where these fish actually spawn before they settle in the harbor?
Yeah, so to my knowledge, this was the last sampling year was 2023. They didn't go out this year. I think that was the end of the project. I know Katrina, the PhD candidate heading this, she has done a lot more work with it. And I bet she would probably have some data or more inferences about the spawning, but I just only did the aging, so we didn't look into that on my part.
Wade, they had a awful time trying to find the spawning fish. They tended to not be where we expected them to be.
Thanks, Scott.
Other questions? I don't see any, so we can end it there. Just to tell you that next Wednesday, sorry, it's a short notice, that Dr. Tara Dolan will be talking about winter flounder stock structure. So I'll send out a link on Friday, and so that you can have that earlier than the one I sent out yesterday. All right. So thanks for showing up, and hope you can join us for some future seminars. Thank you, everyone.
Thanks, Gary.
Thanks, Kara.
You need me to stick around, or are you all set?
No, I'm all set.
All right.